Welcome back to Astronomy 104, the astronomy of planets. In this module, we're going to complete our exploration of the history of astronomy up to the 20th century. So in the last module, we explored the origins of science. We looked at how science can and can't be used to explore the world and learn things about it, and how science is supposed to work, how it's not supposed to work. And as we looked at the early history of astronomy, we eventually made our way to Ptolemy's model, which was the most successful scientific theory to describe the motions of the planets in the ancient world. So in this module, we're really moving on from the question, what is science, to the next question, which is how has science actually been done? So we know how science is supposed to work, how it should be done, and in this case, we're going to look at a series of scientific revolutions that took place over 2,000 years, and how it has actually happened. So the eventual outcome will be a qualitative discussion of Einstein's general theory of relativity, and why it's currently considered our best description of solar system orbits. So to get there, we'll be looking at the history of events that happened over that time. We'll be looking at how the works of many individuals solved problems, how specifically those problems were solved. We'll be looking at why the theories were eventually accepted, which is generally because they offered a better description than previous theories, but also why developments took so long. If they did provide a better description, why did it take as long as it did to eventually, for the theories to eventually be accepted? So overall, the material for the module is going to break up into 6 parts. There's the 1400 years that took place between Ptolemy, the time of Ptolemy, and Copernicus, and so we'll be looking at what happened during that time. Why did it take so long for any real significant development to occur? Were there any sort of minor things that happened that were important, or did everyone just accept that Ptolemy was right and forget about it? Then we'll move on to Copernicus, what his problems were with the Ptolemaic model. He called it a monstrosity. He hated the equant, but he also really liked things like uniform circular motion. So move on to Kepler after that. So first 3 parts, I guess, are 1400 years between Ptolemy and Copernicus, then Copernicus, Kepler, his theories of the universe, which are quite interesting, Galileo, and his discoveries with the telescope and his troubles with the church. We'll then move on to Newton and his theory of universal gravitation, and finally Einstein. So these 6 parts, there's a lot of information to cover. Understanding how science evolved through the work of each of these individuals and why their work succeeded in bringing about changes. The changes that it did means exploring the material in some depth. And so because there's a lot of material to cover on the subject of scientific revolutions, you'll be given 2 weeks to get through this material and join in on the discussion. There are also supplementary resources included with the module, but they aren't required reading. So the only required reading for this module is the learning material. And so you should plan to get through the material at least up to Galileo in the first week, and then finish the remainder of the material and join in the discussion in the second week.